Okay, we're looking at mini test week 29, question 1. So we're given the position vector of a particle, and we're asked to find its velocity. So let's have a think about that. Okay, so there's the question. Okay, so I'm given the position vector. So I'm told that r is 4 root t. Now, I know I'm going to need to use calculus here, so I am going to just immediately write root t as t to the power of a half, and plus 2t cubed j, and I'm told that t is greater than or equal to 0. Okay, so what you need to know to be able to answer this question is that velocity is the first differential of displacement or position. Okay, so, and then the other thing is that you can just differentiate the I vector and the j vector separately. Okay, so as long as you're happy with that, then this is relatively straightforward. So differentiating the part I've highlighted in green, so I'm going to multiply by the half, and I'm going to reduce the power by 1. So that's my differentiated I vector. Then I'm going to differentiate the 2t cubed. So I'm going to multiply by the 3. I'm going to reduce the power by 1. And that's my j vector. Okay, so that's my velocity vector. They then ask me for a particular value of the velocity. So when t is 4, so I'm going to substitute 4 into each of those coefficients. So that will be 2 times 4 to the power of minus a half for my I vector, and 6 times 4 squared for my j vector. So you can put that into your calculator, but 4 to the power of minus a half is 1 over the square root of 4. So actually that's going to end up being 2 times a half. So that's actually just going to be 1i. And then I've got 6 times 16. So it's early in the morning, so I'm going to grab my calculator. Okay, so then 96j. Okay, and there is my answer to part A. Okay. Oh, actually, now I'll tell you what, one thing I will add is units. So that's going to be meters per second. Okay, so that's part A. So part B, now this comes up a lot, and this is a really easy finish to the question. So for part B, I need, so we're missing a space there, I'll add that in. I need the speed when t is 1, and then we'll think about the direction afterwards. So if ever they ask you about sort of the direction something's moving in, the way it's moving, that's going to be to do with its velocity. So let's just substitute in, so all I need to be able to see is the velocity vector. Right, so now they've changed the value of t. So when t is 1, so now I'm just substituting, just scroll down a little bit, now I'm just substituting 1 into this. So 2 times 1 to the power of minus a half is just going to be 2, and 6 times 1 squared is just going to be 6. So at least we've got quite a nice easy value of t to substitute in. Okay, so then I want the speed. So that's the velocity when t is 1. So the speed is really straightforward. So all that vector is saying is that it's moving 2i, so that's 2 to the right, and 6 up. So if I just do that, so that's the direction it's moving in. So that would be the resultant vector. So the speed is just going to be the magnitude of that vector. So that, and obviously I and j are perpendicular to each other. So that is just going to be Pythagoras. So the speed is going to be the square root of 2 squared plus 6 squared. So I get that to be root 40. And we haven't said how to give your answer, so we could simplify that as a surd. So that could simplify to 2 root 10. And the units would be meters per second, or let's get it as a decimal, or we could give it to 3 significant figures, so that would be 6.32. Okay, and that's my either of those be my answer to part B. Well, sorry, be my answer to the speed for part B, which will answer the whole question. So they also want the direction. Well, seeing as I've sketched it out, that's quite easy to see. So the direction we're just going to give as an angle. Sometimes it might specify a bearing, but not for this question. So how can I work out that angle theta? Well, that's just really simple trig, isn't it? I've got the opposite and the adjacent sides. So it will just be tan theta is opposite over adjacent. So theta is arctan of 6/2, so arctan of 3, which is 71.6 degrees to three significant figures. And my diagram makes it clear which angle I'm finding, but I could also specify that's so. How do I get rid of that? Right. Okay. So scroll down a little bit. Yeah, so for my diagram, it is clear the angle I'm finding, but if we just really want to clarify, so that's the I vector. So one thing you can say is it's 71.6 degrees, not with 2, 71.6 degrees, in the end, right, above the I vector. Okay, and the job done.